All right, so in this first example, we have x minus 1 times x plus 1. And we should recognize this is the difference of two squares. But if you don't, guys, remember you can apply FOIL, right? Multiply everything times everything. So x times x is x squared. X times 1 is x. Negative x. Negative 1 times 1 is a negative 1. Again, you can see the middle terms cancel or add to 0. So you're left with x squared minus 1, right? So in reality, though, again, with the difference of two squares, a minus b times a plus b is a squared minus b squared. You can really, instead of doing all this work, just multiply the first two terms and multiply the last two terms. Because the middle terms add to 0 every time. So in this case, I have sine of x times sine of x is sine squared of x, right? Don't do sine of x squared. 1 times 1 is negative 1. Now, here's where it kind of gets a little confusing. Is that the, could we maybe simplify that a little bit more? We see a squared. We see sine squared. Do we have an identity that represents sine squared? The Pythagorean identity, right? It doesn't always work, but follow me here. Let's do a little sidebar. If I said cosine squared of x plus sine squared of x is equal to 1, what is sine squared of x minus 1 equal to? Well, could we rearrange this so it looks like sine squared of x minus 1? Yeah, we could subtract the 1, and we could subtract the cosine squared of x. Therefore, we would get sine squared of x minus 1 equals negative cosine squared of x. Oh, so actually, maybe the multiple choice answer on our test is negative cosine squared of x. So we need to recognize that. You guys see it? OK, next one. Now, this one doesn't look very simple to multiply. But again, do I recognize the difference of two squares? A minus b times a plus b. So just multiply the first two terms, the last two terms, right? 1 minus x squared. Done. Right? And we've done those a lot. I've given you guys a lot of those 1 minus x squareds. So here, I can do the same thing. 1 minus sine squared of x. Right? You can see I'm doing the multiplying very quickly. I don't need to do FOIL. I recognize the I recognize that difference of two squares. And then what do I recognize this to be? Well, again, go back to my identity. What if instead of subtracting a 1 and a cosine, cosine squared of x plus sine squared of x equals 1? What if I just subtracted a sine squared of x? Cosine squared of x equals 1 minus sine squared of x. So do you guys see how these Pythagorean identities can be manipulated to get what we need? 1 minus sine squared of x, guys, is equal to cosine squared of x. So we could simplify it even further, right? And again, right now we're just practicing, playing with these things. I'll give you guys better directions here later so we can work on these. Here we can distribute. So this becomes x squared plus x. So here we'll distribute. Sine squared minus sine of x. Nothing really we could do. I mean, we could convert sine squared if we need to, but we'll just leave it there. Oh, don't forget the x, right? Don't make that mistake. And then last but not least, x plus 1 squared. So again, what is the biggest mistake students make? No, guys, remember, x plus 1 times x plus 1. We actually did this on what? Day 2 of polynomials. Remember binomial expansion? You expand the binomial. You're multiplying those binomials. So again, here's FOIL. If you want to do FOIL, I did an example over there. I'm going to cut to the chase. This is a perfect square trinomial. First two terms are squared. Last two terms are squared. 2 times the product of the inner. So you just take the two inners and add them up. So in this case, x squared plus 2 sine of x plus 1. I can do that rather quickly. If you're not comfortable with it, then just multiply it out. That's fine. OK? Yes? Questions? No? OK, good.